Hello, my name is Suyash Sharma and I am going to present DSP term project. So the problem statement given to me is design and implement DFT magnitude spectrum based pulse rate estimation using PPG signal. The sampling frequency given to me is 100 Hz. PPG, photoplethysmography, is an uncomplicated and inexpensive optical measurement method that is often used for heart rate monitoring purposes. PPG is a non-invasive technology that uses a light source and a photodetector at the surface of skin to measure the volumetric variations of blood circulation. The use of optical sensors nowadays is very common in the area of non-invasive diagnosis. This is mainly because of their salient features like simple construction, low cost, easy to use, relatively inexpensive nature, etc. PPG sensor is one among the wide variety of optical sensors available and is used to measure the blood volumetric changes occurring in the various parts of the body. PPG signal contains rich source of information related to cardiopulmonary system, but the major problem associated with the signal is the motion artifacts, causing corruption in the original PPG signal. Now we will discuss an example where PPG can be used. Anesthesia is a medical intervention to control pain during surgery by using medicine called anesthetic. It can help by preventing the nerves from carrying pain signals to brain and controlling blood flow, blood pressure, heart rate, and rhythm. Anesthesia uses three different types of drugs, which are muscle relaxant, analgesic, and anesthetic. Monitoring of pulse rate during anesthesia is very important to avoid hypoxia, hypotension, and cardiac dysrhythmia. One of the ways to measure pulse or heart rate include PPG. The PPG can be used to detect blood volume changes in the macrovascular bed of tissues because it is a simple and low-cost optical technique. A PPG is obtained using a pulse oximeter with two light emitting diodes, emitting red and infrared light, which illuminates the skin and measures changes in light absorption. The blood that is still carrying or is saturated with oxygen is measured with a clip-like device called a probe, which is placed on a finger tip. The differences between the oxygen poor versus oxygen-rich hemoglobin are obtained from the comparison and calculation of the probe that consists of light detector, microprocessor, and light source. There are two different types of light at one side of the probe, which are infrared and red. The infrared light absorbs the oxygen-rich hemoglobin, and the red light absorbs the hemoglobin without oxygen. Now we will look at mathematical expression and methodology. This presentation includes simple method of measuring pulse rate from PPG using fast Fourier transform FFT. The FFT is an algorithm that determines discrete Fourier transform of an input significantly faster than computing it directly. DFT can be applied on sample signal. The endpoint DFT can be computed using the following equation, which is x of k equal to sigma n equal to 0 to n minus 1 x of n e to the power minus j 2 pi k n divided by n, where xn is the discrete time signal and capital N is the length of the signal. Then FFT analysis converts the time domain into the frequency domain. Once the frequency is measured from the spectrum, pulse rate can be obtained from the following equation, which is pulse rate equal to frequency times 60. Now we will look at the process for pulse rate estimation. So to determine pulse rate, first we will perform FFT analysis and then compute pulse rate by identifying frequencies corresponding to peaks obtained. Now we will look at the source code. This is the source code to plot magnitude spectrum and to plot PPG signal. Here we have sampling frequency which is equal to 100 Hz. So now we will load the data. The signal length is 1000. To compute DFT, we'll use FFT in inbuilt function for faster calculation. We know that FFT signal length should be of power 2. As in our case, the length of the signal is 1000, so nearest power of 2 is 1024. After the after that, we have calculated DFT for given signal length, and then we have calculated frequency of given signal length and sampling frequency. After that, we have plotted single-sided amplitude spectrum. So here we can see that the graphs obtained. The first graph is the plot of FFT spectrum of PPG signal, and second is the plot of PPG signal. Now we will use peak detection for finding the corresponding frequencies to estimate the pulse rate. For this, we have used the inbuilt function find peaks to plot peaks in the graph, and frequencies are recorded in f logs. And finally, to calculate pulse rate, we multiply the corresponding frequencies with 60 to get beats per minute. Now, this is the code in which I have not used the inbuilt FFT function for calculation. Instead, I have used the mathematical formula to obtain DFT. So here we can see that I have used the formula x of k equals to x of n e to the power minus j 2 pi k n by capital N. And the rest of the code is similar to the previous ones, in which I have found the peak and plotted the single slide amplitude spectrum and we have to note that in the above code, DFT was calculated by using formula of DFT. FFT built-in function was not used. Now we will look at the results and observation. So in above table shows calculated pulse rate for 5 samples using FFT built-in function and without it. It was observed that there was only slight difference in above two methods. The difference in pulse rate measurement is due to the accuracy shown by built-in function. Since the difference observed was small, we can say that FFT analysis can be used for pulse rate estimation using PPG signal. Normal pulse rate for adults ranges from 60 to 100 beats per minute. So the obtained data from the previous table shown that only sample 3 and sample 4 have the near to correct pulse rate reading. Generally, a lower heart rate at rest implies more efficient heart function and better cardiovascular fitness. Now we will look at the challenges faced using PPG signal for pulse rate tracking. Automated analysis of PPG has made it useful in both clinical and non-clinical applications. However, PPG-based heart rate tracking is a challenging problem due to motion artifacts, which are main contributors towards the signal degradation, as they mask the location of heart rate peak in the spectra. The practical analysis system must have good performance in MA removal as well as in tracking. So finally, we will look at the demo GUI. So above is the demo GUI of DFT magnitude spectrum of PPG signal. In the GUI, there is a load button, and after pressing the load PPG signal, it will load the PPG signal and we will get the magnitude spectrum as shown. Thank you.